So this is the second lecture on the ship geometry. The first one I have discussed how what are the lines planned, what should be done, and how to arrive at the lines. Now here let us discuss about the lines itself and what are the definitions of these lines. So lines drawing. So we have come to this final parameters of the ship has already been fixed. That is the final design. From the preliminary design we have obtained, and here we come to this line. Now here you will find that now the lines drawing follows certain engineering principles. That is basic engineering drawing. That is your first angle projection. First angle projection method. Now in the first angle projection method of engineering drawing, you will find you draw the elevation on top. This is your elevation, and below the elevation you draw, one draws the plan, and at the side of course you draw the side elevation. Now actually naval architecture being a very old subject, there are certain practices which are a little bit away from this first angle projection. I will just tell you. So this is your these are the three views, or rather these are called views or views to be drawn. So here you have basically three views to be drawn, and how you draw it is by means of what is called orthographic projections. Three views to be drawn by orthographic projections. Orthographic, as the name suggests, that is perpendicular projections on vertical planes. That is called orthographic projections. Now here the elevation is normally what is called the profile or shear plan. The elevation in your engineering drawing is called the profile or sometimes this is also called shear plan. Now how this plan is obtained is you take, suppose the ship, say this is your this is in the three-dimensional view I am drawing. Now you make or delineate what is called a center plane. This is your center plane. Now where this center plane intersects the hull. So the outline of the boundaries of the hull found by cutting the center plane will give you what is called the profile of the ship. So here you will find normally it is the definition of the profile. profile definition you can write like this. It's a vertical plane called the its center plane intersects the hull form at the center line. So this is called the shear plan of the profile. Now the basic features of this shear plan you will find. So it should show the boundaries of the ship. So this is your called the baseline. So you have to fix up a baseline or what is called the datum line. Now next, the intersection of the hull form with the center plane. Intersection of the hull form with center plane will give you what is the forward shape of the stem. So this is called the bow of the ship, BOW. So your datum line, that is the lowermost line, which is called the baseline. Then you have on the right hand side that is called the bow, and at the aft end or at the rear end of the ship you will find this is called the stern. So I have got at the center plane these three lines defining the bow, stern, the baseline, and you have the deck line. So normally this is called deck at side. And if you want to draw, of course, you can also draw the deck at center. That is the deck at center should have been drawn, but the practice is to draw the deck at side. So this is your profile. So that means the intersections of the hull form clearly depicted on the center plane. Now there are other, of course, there are other. This is one vertical plane. You remember that you are always making what is called orthographic projections. So this is the profile. There is intersection on the center plane, which is also nothing but a vertical plane. So this will come on top, and just below the profile you draw another plan which is called the half breadth plan. So this again is going to be your center line. So sorry, your reference line is always going to be your center line, and you draw the breadth of the various water lines. So that will be depicted in what is called the half breadth plan. Now there are more lines which will come, which subsequently I will draw. And on the right hand side you have to draw what is called the sections of the ship, that is vertical planes which are going to cut your or intersect your hull at right angles transversely. So those are depicted on the right hand side by another plan which is called the body plan. So, here also you draw the center line of the ship by means of a vertical line, and the sections will be shown in this manner. That is, forward sections on the right hand side, and your aft sections on the left hand side. So, that will be your body plan. Now, these plans are made by intersections of planes, orthogonal planes with the hull form. So, profile you will get, profile is obtained by intersection of the center plane with the hull. Now, this one single plane you will find does not properly define the ship. Okay, this is the middle of the ship, and you will find a mark like this called Makeshift. And let's come back to the three-dimensional view once again, where I have shown the intersection of the center plane with the ship itself. Now, what is done, you will find if you take the vertical longitudinal plane at some distance from the center plane and again make an intersection. Sorry, this plane again is going to cut the ship at a certain distance, say this distance, say around say 2 meters from the center plane. Then what will be the shape of the intersection? Of course, the intersection will not follow the same shape as your profile or shear plan, isn't it? But it will be the curve will be within this boundary, isn't it? Because the ship is becoming narrower as you go from the center line or center plane towards the side. So, you will find another curve which will come like this. Actually, I have to follow certain diagram. Here it will become tangent, and here you will get the shape like this. So, you can see that this curve is, is within the extreme outer boundary governed by the center line. Sometimes this is also called the center line buttock. So, this curve is called a buttock. So, this buttock actually gives the intersection of the hull form by a vertical plane which is positioned some distance away from the center plane. So, like this you can draw a number of buttock lines. Say here this is normally buttock lines are given by certain number. So, this is the first buttock, say buttock number 1, and on the half breadth plan is nothing but you are looking from the top, isn't it? So, you will get the outline of the buttock line will just be a straight line in the half breadth plan. Say this will be your buttock number 1. Now, these buttock lines are equally spaced, and if they are not, if you have in between one buttock, then you have to specify it, say that is half meter buttock. So again you make another vertical plane and intersect the hull form at say at an equal distance away from the buttock number 1. So this will give you the first buttock. Similarly, you make another intersections with another vertical plane, then you have buttock number 3. Sorry, this will be buttock number 2 rather. Yeah. Like this you go on till you come at the extreme side of the ship. That also can be drawn, isn't it? The extreme side of the ship you can also draw and say this will come, sorry, here it is not drawn, I think. This line will come much below. There is some mistake in my drawing. So this is the profile. So all these curves you can see that they are within the extreme, the centerline curve, the center plane or the centerline buttock. So this curve should be clearly depicted in the profile or shear plan. Sometimes this is also called the shear plan. And buttock, you have shown the buttock by a straight line on the half breadth plan. Now how it is going to look in the body plan? Say this is the position of, sorry, say this is buttock number 2. So half breadth plan is actually, if you draw horizontal planes, if they intersect vertically your hull form, and if you look from the top, so those intersections or the extreme boundaries will be given by these curved lines. So those are called the half breadth plan. And since your buttock is actually a vertical plane, so if you look from the top, you will simply get a straight line. But if you look from the front, that is your profile is nothing but the front elevation, you will get the boundary of the curve, isn't it? So similarly in the body plan, if you look at the buttock, so this will be a vertical line like this. So this is your center line. So this will be the position of, say, buttock 1. This will be the position of buttock 2. The same distance on the left hand side also you can make. So this will be buttock 1, the other one will be buttock 2. Now in the body plan, yes, that is what I am coming to. You will find that the section shapes that I have drawn, that is the intersection of the transverse vertical planes with the hull form, the outlines that are given by these intersections, they are not same on the both sides of the center line, isn't it? Now the reason is simple, that the ship is always symmetrical about the center line, isn't it? If there is some unsymmetry in the hull form, then the ship will not be able to make a straight line movement. That is, it will lose its directional stability and it will turn, try to turn. No? and if you want to offset that, you have to give a helm angle to the rudder. So, because of the similarity of the ship about the center plane, that is geometrical similarity of the center plane both on the port side as well as on the starboard side, there is no need to draw the full sections of the or the transverse sections in the body plan. So, what you do, you draw the forward sections on the right hand side and the aft sections on the left hand side. You need not draw the whole section. Of course, wherever it is necessary, say in the when you are fabricating the ship in the hull shop, you may be required to draw the full section. But then again, it should not be shown on the body plan. Otherwise, that will give erroneous drawing. And this body plan actually you can show either on the right hand side. Normally, in our institute, we draw it on the right hand side, but it also can be drawn in the profile drawing just at the middle. Here also you can draw the body plan. But if you have enough paper in the drawing, it is better to show the body plan separately on the right hand side. So, this is another location of the body plan, and in Comstock you will find that the body plan is neither located at the right hand side nor in the profile view, but it is on top of the profile view. That means the conventions are not strictly followed. However, but invariably you will find the profile drawing and the half breadth plan should go together, and one should be the half breadth plan should be below the profile drawing. So, this is another convention. Actually, that is the problem with naval architecture. A lot of things have come from conventional or from past practices that has all been followed. So, if you have sufficient paper, if you want to draw the body plan, you simply extend the baseline. You simply extend the baseline and draw a rectangle, and inside that you can show the intersections of the hull formed by the transverse planes. So, that is called body plan sections. So, these are the three views that are normally shown in the lines drawing. There are going into the more and more detail, you will find that if you want to draw the plan, you make a certain grid. That means you will find that the shape of the ship is continuously changing as you proceed from the baseline to the deck, isn't it? Both longitudinally as well as transversely. Now, here if you want to draw the lines plan, you should draw first. I have explained that how the molded baseline, but there are other lines which you have to draw, which are called water lines, in order to clearly define the ship. So, these water lines have to be drawn. So, on the profile, after you have drawn the baseline, now as yet you have not started drawing the lines plan, but before that you have to draw all these water lines, or you have to make a certain grid. So, you draw horizontal lines like this. Now, these water lines are positions of what is called water planes. The water lines actually denote positions of water lines given. They give, here you can write down the definitions. Anyway, water lines give what is called water planes. So these water lines that I have drawn, if you look from the front, you will get only a line, but they intersect the hull. That is, there they give the position of certain planes, horizontal planes, which intersect the hull form at specified distances from the baseline. Now, these water lines, you will find the baseline is called water line 0, and again a horizontal plane which is intersecting the hull form, say at 1 meter distance from the baseline, will be denoted by the 1 meter water line. Normally it is called water line 1 or water line 1 meter. So like that you have to draw these water lines. Here actually it is given in terms of both in terms of meter and feet. You go until you arrive at the deck. So this will be say around say 10-meter water line or 12-meter water line. This will be denoted like this. Now once you have marked these water lines, so immediately you can measure the distances from a certain reference point. Either it is the midship, and not at the front you have another reference point which is called the forward perpendicular. I will give you the definitions of this forward perpendicular and after perpendicular, but just right now I am just explaining the rudiments of this line span. So the basic requirement of these water lines is to denote the water planes. Water lines actually denote the water planes, and these water planes, they give the water planes, give the intersections of the hull form with the horizontal planes, and those you can draw on the half breadth plan. So these water lines are also depicted on your half breadth plan. Now here the like this. So these are the different water lines. So these water lines are nothing but the boundaries of the curve, which are the intersections of the horizontal plane with the hull form. So say this will be water line 0, of course, is the base plane, and here this may be water line 1, then this will be water line 2, and the extreme boundary will be given by deck at side. Deck at side is another water line, isn't it? So here these are the things which may constitute your half breadth plan. So the first job when you are drawing the lines is to make this grid constituting, first draw the baseline or the datum line and figure out the length of the ship between the forward perpendicular and after perpendicular, and also the maximum breadth. The body plan should accommodate the maximum breadth of the ship. So this you have drawn, you extend the baseline, and also you extend these water lines on the body plan, say like this. So here this will be water line, say water line 1 meter, water line 2 meters, like this, till you go to the main deck. Say this is water line 10 meters. That is your deck line. So this grid you make. Now obviously you just cannot draw the half breadth plan from the profile, can you? You cannot, because the profile will give you only the longitudinal distances. Now you can only draw the half breadth plan from the body plan. Now body plan, you have already drawn the horizontal water lines, and from the center line you can just mark the distances. Now, distances of the curves, that is the intersections of the transverse plane with the hull form, those are given by these curves, the body plan section. They are called body plan sections. Now, suppose at a particular water line, you get a particular point on the curve, and immediately you can read off this breadth at a particular water line. Say this is water line 10 meters. So, you can calculate or you can offset, these are called offsets. So, you can offset the breadth from the center line from the body plan and mark it on the half breadth plan. But a half breadth plan, you have not drawn the sections, that is the position of the sections you have not drawn. So, again you mark the forward perpendicular here, and this is the position of your after perpendicular. Now, these are the markings which you should make before you start marking the offsets. So, this is your midship section, right. Now, in between these forward perpendicular, the length between the AP and FP you divide into number of equal parts. Okay. You follow? So, this length you divide, that is the length between the FP and AP, you can divide it either into 10 or 20 equi-spaced distances. And here also, and these are called stations. Say this will be forward perpendicular is called station 0. Say this will be station number 1. Then this will be station number 2. Like this, you go to this will be station. I have left out station number 3, station 4, etc. Like this. So after perpendicular will be station 10 or 20. You make 10 divisions, it will be station 10. And forward perpendicular is station 0. Now, these the intersections of the hull form at these stations are marked on the body plan. So, these outlines that you see, they are called body plan stations. So, now we have got these 3 views, and of course, coming back to the definitions, you write that so buttock planes are planes drawn parallel to the profile at fixed distances from the center plane. Shear plan I have already explained. Next is your half breadth plan. So that means this plan that you have drawn on just below the profile is your half breadth plan. So those are intersections of the hull form with horizontal planes, and these are the water planes. Now you can indicate the load water line on the profile. That is normally done. You indicate, say, your load water line gives the maximum draft at which the ship is able to float. So here you can mark with, say, another, say this is the position probably of your load water line, and you can indicate this as LWL or load water line. So that will give you the maximum draft at which the fully laden ship is to float. This is the position of your load water line. Of course, normally the load water line is just indicated on the profile and sometimes on the body plan, but there is no need to draw it on the half breadth plan. Here I do not think they have drawn on the half breadth plan itself. Yeah, somewhere between the baseline and the deck line. So load water line they have not drawn. It's not drawn. No, no, it is drawn. Here it is drawn. You can draw it. It can be drawn.
Station starts from forward perpendicular.
Yeah, normally that is the practice. Stations they are starting from the forward perpendicular. So that is the I think that is the US practice that is followed actually. It can start either from the forward perpendicular or from the arc perpendicular, according to which practice that is normally followed. That is the British or the American practice. So here this is not mentioned. Somewhere I had come across. Anyway, uh, the numbering of the stations are very important. Yeah, so that is the American practice. Customary numbered from the bow. So American practice is the forward perpendicular FP is designated as station 0. Normally we follow this practice only. Forward perpendicular is designated as station 0. And of course in Europe and Japan it is the opposite, that is located at the AP. AP is designated as station 0. So this is the American practice. And this is the British and Japan, European practice. Europe, Japan follows this practice. Of course, that brings us to the concept of what is called the length between perpendiculars, or the definition of AP and FP. Now, here the three things that you should note is that what is this definition of forward perpendicular. The other one is the after perpendicular or aft perpendicular. Now the forward perpendicular is the position of intersection of the load water line with the forward part of the ship. Normally that is called the stem or the bow. So one should remember this. This is your, say, the ship like this, and your load water line intersects the hull at this point. So this is the position of the forward perpendicular. The position where the load water line intersects the bow of the ship, that is the position of the forward perpendicular. So here there is another point which you should remember, that when you are drawing these stations, that is the transverse planes cutting the hull form at particular positions of the ship. Now what happens at the forward end of the ship and also at the stern end, you will find that there is a large amount of change in curvature of the hull. The hull form actually changes vastly near the forward end and also near the aft end. Now here again they will thus be necessary to make what is called the position of another station, which is called a half station. Say this is station half, and here also there will be another station which is called station 1.5. So these also are to be shown in the body plan, and also at the end, at the rear of the vessel, that is from the midship towards the after end, you can also have half stations. So this will be, say, station number 8, say station number 8, sorry, station number 8 may be this one, this will be station 8 half, like that it is to be indicated. This may be station 9 half. So half stations, this of course will be are necessitated wherever there is a gross or there is a large change in the shape of the or curvature of the hull, and these again are to be depicted on the body plan. These half stations you have to draw on the body plan. So whatever stations are shown on the half breadth plan, that has to be indicated or shown on the body plan, otherwise it will create inconsistency in the drawing. That means whoever is studying the drawing, if he sees one half station here and does not find in the body plan, then that will cause certain error in the calculations. So this figure you can see, that is the position of the forward perpendicular. So that is forward perpendicular, by definition you write I have not made the transparency. Forward side of the stem, or sometimes this is also called the bow, with load water line. Bracket, that is called LWL. Now the Americans, they call this, saying LWL, they say that it is the dead water line or DWL, whatever it is. So this is the definition of forward perpendicular. And there is one thing, of course, there is a slight error that is introduced in this definition. You will find what we are aiming at is ultimately you have to make certain calculations. One has to make certain calculations from the lines plan. So lines plan is giving you a predefined shape. Now from this shape you have to calculate the hydrostatics and stability. So next class I will talk about what are the molded dimensions and what are the definitions of the molded dimensions. But actually the position of the forward perpendicular should not be at the forward end of the stem. I mean, in practice, by practice it is coming. Why? Because it is easy to see the intersection of the load water line with the forward end of the stem from outside. But if you want to make any calculation which are based on hydrostatics and stability, you are basing your calculations on the dimensions inside the shell. That is, you are leaving out the shell thickness for your calculation purposes of buoyancy, stability, displacement, weight, etc. So in that way, actually the forward perpendicular should be based on your molded line, but since it is difficult to view or imagine the forward perpendicular, normally from outside we take it as the intersection of the load water line with the forward part of the stem. Now the stem region, you will find stem region is quite thick. You will find that there is a stem bar. Stem bar is somewhat round, and at the bottom this bar is bent like this. So it has certain thickness. Stem bar normally you will find, and at the bottom it joins with the keel, and above of course there is a plate like this, it comes, which is welded to this stem bar. Similarly at the stern portion, so that means your forward perpendicular, actually what you are making is the not this one you are not taking, that is not the inside portion of the stem bar, but you are basing your calculation which is based on the external intersection of the load water line with the forward part of the stem. So this is your location of your forward perpendicular, and this is the load water line. However, for practical purposes, in our this thing here, in our displacement calculation, we neglect this stem bar thickness, that which contributes. Now similarly, your the definition of the after perpendicular. So this is the definition of the forward perpendicular, and the after perpendicular definition is somewhat tricky because it depends on the shape, the stern configuration, and here you have a number of shapes. So at the stern of the ship, that is the below the load water line, you will find the rudder stock to be positioned. So here again you have to make uh, suitable openings for the position of the rudder. So your rudder is coming here. There will be a sole piece on which the rudder will be located, isn't it? And you will have to have a propeller aperture. Your propeller aperture will be given like this. So normally what you say that this is a what type of stern? This is a normal cruiser stern, isn't it? And you have a, you can house your rudder in this location. So this is the position of your after perpendicular or AP, and propeller will be located somewhere here. So AP is the or after perpendicular. Is the position of the rudder stock. Normally that is the position of the AP, where the rudder stock is the closest in the hull, and your the dead water line or low water line will come somewhere here, and this is your molded baseline. molded baseline, and this is your low water line. Now, if you have a spade rudder, so here actually there is one thing that is happening, that if you base your calculation, your hydrostatic calculation based on the length between your FP and AP, you are leaving out this much of volume. Like in the definition of your forward perpendicular, you are making some excess volume because of the stem bar, and here at this turn, because of the location of the AP, you are leaving out some volume, isn't it? So anyway, that is normally acceptable, but say if you have a spade rudder, if the displacement of the ship is quite large, say in tankers and cargo carriers, the so here just I am finishing the drawing. Here you have the house for the spade rudder. So this will be the position of your AP, right? And again here this will come, so your dead water line will be here, low water line. So this is the position of it. So this brings us to the end of the second lecture, and tomorrow I will continue with the other aspects of your lines plan.